So, hello world. My name is Yesu. And I hate a lot of motherfucking things. First and foremost, I hate ignorance. When I say ignorance, I mean ignorance to anything. Ignorance to anything that is beneficial or um, supportive of life. Alright? Now, 80% of you motherfuckers, I hate. It's just like, oh, yesterday I went to the mall with my cousin and we went and bought fucking 3 dresses and 2 shoes. And then we went and ate Subway. And oh my god, I tried the teriyaki chicken for the first time. It was so fucking amazing. Oh my god. I'm a new fan. And after that, we went to the movies and we saw a movie and da-da-da-da-da. Shut the fuck up. Who the fuck gives a fuck? I surely don't. Anybody who comes with small talk, once you start it, I have stopped listening. Automatic. I'm not listening no more. Like, I don't even know what you're saying. I'm zoned in my phone playing fucking Candy Crush. Because guess what? Candy Crush is more interesting than you. Candy Crush has a higher IQ level than you. Shit, Candy Crush has a higher entertainment value than you. Sorry, but it's true. Alright? Now, getting back into this, I really can't, you know, I, I can't even try. Well, I can try. I've tried to even put myself through the misery and pain of listening to you for an hour. That's like torture. That's like, to me, that is the worst torture you could give me. Yeah. Like, that'd be worse than waterlogging or blade slicing or ripping nails off or ripping teeth out. I'd prefer to go through that. Alright. Another thing that I hate is gossip. Oh my god. People who are just constantly talking about people and what they do and what they did and what they're not doing. People who invade. No, I mean, let's not skip subjects, alright? People who just are so fucking busy pointing their noses in motherfucking other people's business. just because you're not, just because you're a pussy and you don't have what it takes to confront yourself and actually point the finger at yourself and actually accept some responsibility for your actions. Alright? People who talk about other people like, oh, I hate him because he pollutes. I'm pretty sure you're a big polluter. Oh, I can't stand that motherfucker because they're a liar. Out of that sentence, probably 1% of it was truth. You see, people who tend to point fingers at other people is because, and no, not tend, people who, I'm gonna absolute this, not a generalization. This is an observation, and it's a very well um, founded Assumption? Yeah, let's call it assumption. No, not assumption. Observation. That's what it is, period. So, here's the thing. I, I'm pretty sure that, I'm definitely sure that when a person points the finger at another person on a specific subject, it's only because deep down inside that person does the same and is the same. And those are the trouble starters. Those are the ones who get the fucking crowd riled up and ready to, like, just go out and do a raid. So, with that being said, I hate people who um, lie. But I was gonna say earlier that I hate. Hold on, there's somebody over here doing some dumb shit, and they're just distracting me. Here we go. Anyways, going back. So yeah, people who give false witness upon other people, you know. I don't know. It's one of those things where I just I hate what I hate. I love what I love, which is generally everything. You know, I love almost everything, even the people I hate. That's crazy. Even the people I hate, I love. I just use the word hate, but it's not really hatred. It's more of a I really can't even fucking stay in the same room with you for 10 minutes without wanting to fucking chop my own head off with a fucking rusty ass steak knife. You know what I'm saying? Or like shoot myself in the head with a fucking 50 caliber 4 times. Well, how do you do that? Well, that's, you can't explain it. It's just what you birth in me, you know? People who are just a waste of energy and time and space, you know? What the fuck? You guys need to wake the fuck up, you know? Really. It's about time that people start to realize what the big issue is. The big issue is the human condition, where we are headed to. What is the purpose and goal of life? You know? What is the meaning of life? Well, I mean, I know. I know. I know for a fact. I know for a fact what the meaning and purpose of life is. Alright? Not opinions, not faith, okay? Physical measurements. 1 second. Physical measurements, stuff that we can actually prove. Alright? Now, your opinion is your opinion, and regardless of it, the facts are never going to be less factual. Alright? That being said, what I'm trying to convey is that you can say, oh, that tree, there you go, is not green, it's yellowish to me, so it's yellow. Okay, well, okay. When you go into the electromagnetic spectrum, you have a section of it very small slither of section called the visible light frequencies. All right, and there's 7 main thresholds of color or visible parts of the light of the photon. All right, now fuck names. Let's call that Brasubra. All right, that color right there, that tree is Brasubra. Right? I don't give a fuck what you want to call it. I go by frequency. So if this is within the, okay, we'll start with the 10,000 kilohertz are the fucking reds, all the way to the 20,000. When you get to the 20,000, that 20,000 kilohertz frequency exactly, all the way to 30,000. So that's 20,001, 20,002, 20, all the way to 30,000 is what we call oranges. And there's all types of orange. The darkest orange mixed in with the red, and the lightest orange mixed in with yellow. Right? And then you got yellow, which is 30,000. 40,000 is going to be green, 50 blue, 60 indigo, 70 violet. All right? Those are not actual frequencies. They're not the actual frequencies of the colors. But still, it conveys the same message. All right? If I needed to know what the exact frequencies were, I go on Google. I don't have to waste my time. Understand what I'm saying, though? So, green is going to be green because it falls within the 40,000 to 50,000. So 50,999 is very, very, very light green. Not blue yet. Still green. You could still see a visible difference. There's still a frequency. In other words, there's still a certain amount of crests and troughs within a space. So if I have a space this big and it represents 1 second and I only have one crest and one trough, then that's a half frequency. I'd have to have 2 crests and 2 troughs. And that's going to be a frequency of 1. All right? But if I have the same space in 1 second and I have wave, then that's going to have at least 100 frequency. Therefore, it's completely different. So guess what? Same applies to color. The colors are just different frequencies of light that we perceive. And because there's no such thing as color, only absence of light. But that's not the point. The point is, they're categorized because they are different. Okay? So, let's go back onto the original topic, which is the purpose of life, alright? So, your opinion can be opinion, but the facts are the facts, alright? Now, life happens not, well, it happens because of a random set of occurrences, but the way it happens is not random at all. It's very, very specific. So, a couple of the factors, as we know now, are basically distance from sun, rotational speed, chemical composition. You know, um, there's a lot of factors, all right, that are very important towards sustaining life. And once you meet certain ones of them, then in liquid water or other liquids, because we don't know other types of life that might be based on silicon instead of fucking carbon. We're based on carbon. All life on Earth is based on carbon. Basically, in other words, carbon is essential for attracting other elements that build chains called RNA, ribonucleic acid, all right, and much less complicated proteins that carry out functions just because of their relationship towards each other. All right, so remember this: every single element in the periodic table of elements, and let's start off with the hydrogen, which is the building block to all matter, right? Hydrogen has one proton coupled with one neutron and one electron going around it. Now, when you take this hydrogen atom and you take another one just identical to it, they have one proton, one neutron. So therefore, they're neutrally charged. I mean, honestly, I believe it's just a proton and an electron. I don't think there's a neutron. I don't remember. Just maybe it's a proton. The point is, it has a charge, not a net neutral charge. And every time they encounter each other, they repel at the last second. So they'll be flying in random space, just because hydrogen is a gas. And it's the lightest of all because it's one proton. So, it's very light compared to something that has two protons, which is helium. But hold on. So as they fly around in space, and randomly two of them approach, at the last second they will repel each other and fly in off directions because of the magnetism, right? So the electron disposition defines its magnetic attraction or repulsion, and cool. So anyways, alright. So anyways, they repel each other, right? But when you have a lot of them massing up somewhere, in any random spot in space, really having issues. Cool. Alright. So they repel each other. But when you get, and here we go, I have to explain another important factor so that you can furthermore understand with a more clear, with a clearer understanding, because visuals always bring good understanding. So these protons almost collide. You get a lot. Now, the way gravity works, or the way our universe works, is you have to, okay, space and time are one solid, not solid. Imagine taking a grenade. Slow motion explosion. Now, this wave, this outer wave, this force wave that's pushing out in all directions, it's not physical, is it? I mean, imagine if it was paused. Would you be able to sit on it? No. Or maybe, if it's strong enough, if it has enough force, maybe, I don't know. But the point you have to understand is that it still physically reacts to everything around it. So if I were to have an explosion going outward in slow motion, and I have a little piece of matter right here, when it touches it, it's going to make a tiny indent in it. See, even if it's microscopic, it's still gonna, it could be a little grain of dust. And when it touches it, it's gonna a little bit. It's gonna mold it to it. So you gotta visualize that, because that's important. That's exactly what's happening in our universe. Alright? Hydrogen, which was the first element, there was a lot of it, and it started to ball up. So as this is growing, all of the little hydrogens that are all over the place are getting closer to each other on the expanding mass, and as they do, they start to make a bigger indent on this bubble. Okay? So that indentation As it gets deeper, the atoms of hydrogen fall faster in towards it, and it comes to a point where it gets so deep because there's so many different little atoms of hydrogen in the same spot that they make such a big indent that the speed that they achieve as they're rolling into the indentation supersedes the repulsion force of the protons, and they actually fuse and they make helium. Now, helium is 2 protons, 2 neutrons, 2 electrons. I'm gonna go very basic so that those who don't have any type of chemistry background can understand no matter what. So let's just go back to the 111. Now helium is gonna be 222 because you just crashed 1 proton, 1 neutron, 1 electron, 1 proton, 1 neutron, 1 electron. Now you have 222, 2 protons, 2 neutrons, 2 electrons. Now that helium, if you take it and you add another hydrogen, make lithium, which is 333, and then you take another 111. Now you have 444, which is beryllium. Then you boron, carbon, number 6, nitrogen, oxygen, fluorine, neon, so all the way to 118. All right, you just keep adding 111, 111, until you make 118, 118, 118. All right, ta-da! Basic, very rudimentary, very raw, completely, isotopes, ions. We're completely ignoring all of those, and we're just. This is so you can understand. So, when you have these little electromagnets, keyword magnets, remember that word because it's very important. It's actually one of the most important factors, period. Maybe hydrogen and hydrogen don't bond together. But if you take a hydrogen and you bond it with a lithium, maybe it'll attract hydrogens. All right? These magnets work in funny ways. And what I mean is, if you say, let's talk about Lego pieces. You have 118 different types of Lego pieces and, infinite numbers of each one. Maybe this piece doesn't fit with this piece unless you use this piece in between them. So when you have a star, which is a collection of hydrogen, which is the big gas, you see the big gases, nebulas in space, those are just hydrogen and helium, and they get so big that they make such a big indent that they start to, and every time atoms fuse, they release energy, and that heat actually makes other atoms more prone to crash into each other, bypassing the repulsion. At that point in time, the indent keeps getting deeper, deeper, deeper. The heavier ones, like the helium that is formed, they start to lose momentum, so they stay more towards the center, okay? While the hydrogens are they're just riding the whole bowl because they're so lightweight, all right? Now, remember, as they keep crashing into each other, they keep forming helium, lithium, beryllium, boron, until they make iron, all right? Now, once they start making iron, they can't fuse no more because the deepness is not strong enough to bypass the hydrogen crashing into the iron. It's all, no matter how fast it's coming, when it comes to it, it's going to be repulsed at a far distance, so therefore it's never going to hit it. If it gets close and it repulses at the last moment, then yeah, but this has such a strong repellent force, and this is so lightweight that it repels it way far away, so you can't fuse anything after iron in most stars. I say most because there's bigger stars that may be fusing other elements, but that's not the point. Once you start forming iron in the core, then you can't keep the fusion reactions going on, and what happens is supernova. And when supernova occurs, it starts releasing lava of all the elements up to iron, which is number 26. All right, so all of the elements up to number 26: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, carbon. I forgot. Wait, forgot the order, but no, fluorine. Yeah. Doesn't matter. Oh, sulfur, nickel, copper. No, sulfur, nickel, sulfur, nickel. The point is, up to 26, all of those elements get spewed out in all directions when the supernova occurs, and those chunks get into open space and they freeze, and when they freeze, they become asteroids, comets, meteorites, and those asteroids, comets, and meteorites that go in all directions, they leave the bowl, and they go out on a flat surface, and then they go into another bowl, which is another star, and they start to asteroids, comets, meteors. Ow. They start to collide and what do you call it? Clump up and make planets. Now, when a planet is made that has the correct chemicals on it, then, other asteroids with water on them crash into him and cool it down, because once those big comets crash, they're creating heat. So these are big balls of lava, just straight lava. But then when you get asteroids with ice on them, and they start cooling it down, and that creates a vapor, which is the atmosphere. It's the bubble. It's a bubble of air. Okay? It's a bubble of air that's stuck around this rock bubble. So, this heating and vapor creation and, cooling creates conditions to where if you have the correct elements on this planet, then in the water or in the liquid, they'll start to magnetism again. The right elements will start to and attract to each other and build chains and build proteins and build RNAs, and they'll start carrying out reproduction methods of just it's natural. It's magnets. So if you have magnets that are just going to keep attracting other magnets and putting them in order, it's random, but it's not random. It's random that it occurred on this planet because luckily this planet was hit by these asteroids. That was random, but the action of the elements attracting to each other in certain chain forms is not random because it's magnetism, electromagnetism, and meaning depending on how many electrons it has is going to define its magnetic output. So these chains form, and they just keep attracting other magnets and keep building until you get plants, and the first plants start to say, well, hey, I don't need just the magnets. I could probably get these heat coming with these ultraviolets and all these other radiation forms and light forms and heat forms, and and they start building onto it. So in other words, the leaf just takes the elements that hit it, and it keeps building the leaf, and the leaf, it just builds like that outward. Okay, so once you have plants, that starts to change the atmosphere. In other words, the gases. And once you change the gases, now the elements that can attract each other inside the oceans are different. And you start making different chains. You make the chain for the fish, you make the chain for the birds, you make the chain for the reptiles. They occur in different places. Multiple of them are occurring at all places on Earth at all times. So, you have a reptilian DNA over here in Africa, another one over here in North America, and they're just forming in random locations, but the same chains. Why? Because that's the way these elements, when they encounter each other, are going to build upon each other. Shit. What can I say? Alright, guys, I'm going to have to pause for now.